So this is going to be part 2 of 6.6. I'm worried there's going to be a part 3. We'll just see what happens. For the next group of problems, at least between 25 and 38, I'm going to do the following steps. Each problem is written as a logarithm, and I have a heck of a time solving the problem when it's written as a logarithm. So I'm going to rewrite the problem so it has an exponent following these steps. So this is going to be how I'm going to start each of the problems between 25 and 38. I'm going to rewrite the problem in exponential form, and how we did that is we're going to scratch out the logarithm. The base of the logarithm will be the base of the exponential function that I'm trying to create. So the base of the logarithm is 2. It's going to be the base of the exponential function. I'm going to switch. I'm going to make the number to the right of the equal sign, this 3, an exponent, and place the argument to the right of the equal sign. So that's following the steps. I scratched out the log, I made the 2 the base, I switched the 3 and made it an exponent and moved the 8 off to the right, the 3 off to the left hand. I made the 3 an exponent, I moved the x off to the right hand side, and this is simple, I'm done. And I'm going to check, probably on both calculators. So for checking, I need to make sure that the log base 2 of 8 equals to 3. On my calculator that has log base, super easy to check. On this calculator, to check just isn't showing up. It's a lighting thing so much with this calculator. If I hit my math button and go to log base and just enter the log base 2 of 8, you'll see that it equals 3. On this calculator to check, I need to do log of 8 divided by log of 2. And it also equals to 3. They both check just fine. So same thing for the next problems, but there's a twist. In problem 27 and 28, in order to write this as an exponential function, I can't have shorthand. I need to see the base. And I know that the ln of any argument is the same as the log base e of that argument. So before I could actually do this step 1, I need to think of problem 28 in non-shorthand mode. So the ln of x is the same as the log base e of x. ln is just a shorthand, which is nice, but it's not good for this algebra. Now I'm going to rewrite the problem in exponential form. I'm going to scratch out the log. The base e is going to stay low, and I'm going to switch the 0 and the x. The 0 is going to become my exponent. The x is going to bounce off to the right. This gives me e to the 0 equal to x, and I know that anything to the 0 power is 1. I claim my answer is 1. I'm going to check, and I don't need any special calculator to check here because ln is a key on both of my calculators. On both of my calculators for checking, I just type the ln of one button, type the number 1, hit equals to make sure I get a true statement, which I do just fine, so I'm good there. It checks just fine. There's a parenthetical comment on the next 4 problems. Not so much, well, a little bit because of the algebra, but a base has to be positive. So if the algebra could produce a negative and a positive solution, bases of logarithms can only be positive, so I can only have positive solutions. And so I won't worry about generating negative solutions. And let's do 29 together. So that parenthetical comment just tells me logarithms only could have positive bases, and the x is written as the base. So because I'm only allowed to have positive solutions, when I do the algebra to get the x isolated, I'll do something less than what I might do if I'm allowed to have negative solutions. So step 1, the problem is the log, and problem 29. The log base x of 49 equals to 2. I need to write it in exponential form. How do I write it in exponential form? I cross out the logarithm, I leave the base subscripted, and I switch the role of the 49 and the 2. The 2 is going to become the exponent, the 49 is going to go to the right of the equal sign. Normally, this kind of problem I would solve by square rooting the left-hand side, plus or minusing square root the right-hand side. But because I don't allow negative solutions, instead of doing plus or minus the square root, I'm just going to do the square root because I don't worry, I can't have negative solutions. It will never check. On the left-hand side, the square root of x squared, square rooting cancels out exponents of 2, and this leaves me with an x. On the right-hand side, the square root of 49 is 7. I claim that's the answer. Let me check to see if the log base 7 of 49 equals to 2. On this calculator, to do the left-hand side, I do log of 49 divided by log of 2, log of 7, should I say. And I get 2, which is good because that's what the right-hand side is. On this calculator, I would just log base it. Math, find the log base, do the log base 7 of 49, and make sure that that equals to 2, which does just fine. So all the way up to 38, I'll be doing the same strategy. Solving is weird. We haven't done much solving like this, but it's not so hard. So 32 is going to solve similarly to your 31, so I'll save you the 31. So the log base x of 32 equal to 5. The parenthetical comment means I just can't have negative solutions. I'm going to scratch out the logarithm. The x is going to remain low. I'm going to switch the roll of the 5 and the 32. And I get x to the 5th equals to 32. To solve this, instead of square rooting both sides, I have to 5th root both sides. When you do problem 3, you're going to cube root both sides. So the 5th root of x to the 5th, 5th rooting cancels out exponents of 5 and leaves me just with an x. To do 5th root on this calculator, I type the number 5, I hit the math key, and I go down to option 5, which is, we'll put anything in for my root. And see how it made a 5th root for me? And then I'll type the number 32. And the 5th root of 32 is just 2. So the answer is 2. On this calculator, to do the 5th root of 32, I type the number 5, I hit the math key, I go down to option 5 and hit enter, and it doesn't put the 5 in such a nice place, but that's how I'm going to have to enter 5th root of 32 on this calculator. Again, I type the number 5, hit the math key, go down to option 5 and hit enter, type the number 32 and hit enter, and I see the 5th root of 32 is 2. That, I believe, is the answer. Now I need to check. For checking, I just go back to the original problem and see if I change the x to 2, if I'm left with a true statement. And then I'm only going to check on one calculator. I'm assuming you can check on the easy calculator. So I'm going to see if the logarithm on the left-hand side equals 5 to make the left and the right-hand side the same, which it does. Same parenthetical comment, doesn't impact my algebra at all. Just as going to, I just can't have negative solutions. So for 34, same structure, just the algebra is a little bit weird. So the log base x of 4 equals to 1/3. Scratch out my logarithm. This is going to give me x to the 1/3 power equals 4 after I switch. Now I have multiple choices. I'm going to rewrite this as a radical. I think that's more easy for me to explain. So on the left-hand side, fraction exponents can always be turned into a radical. The denominator becomes the index, and everything else becomes the radicand. So cube roots result from 1/3 power. The x to the 1/3 power simplifies to the cube root of x to the 1st power, and that's really just the cube root of x. I'm going to solve now by cubing both sides. Cubing cancels out a cube root, leaves me with an x, and on the right-hand side, I can do 4 cubed without my calculator. I claim that's the answer. I should check to see if the log base 64 of 4 equals to 1/3. My guess is when I do this on my calculator, I'm going to get a decimal, like 0.333. I hope I can make the decimal into a fraction. I don't know how smart my calculator is. So I'm going to do log of 4 divided by log of 64 on this calculator. I get 0.3333. If I hit math and enter twice, tells me that it's 1/3. So I get 1/3 equals to 1/3. On this calculator, I could have entered math, go up to get log base, the log base 64 of 4, and still the same issue, decimal to make the decimal into a fraction. You hit the math button, enter once, enter twice, and you'll see that it checks just fine. 2 more problems and we have to get to a new problem solving strategy. So 36, same structure. In problem 36, I'm going to write the problem in its exponential form. And to write the problem in its exponential form, scratch out the logarithm, leave the 3 as the base of an exponential function, switch the 2 in the x minus 5. The 2 becomes an exponent. The x minus 5, when it's freed up from the logarithm, doesn't need to be in a parentheses anymore. Now I'm going to solve this. 3 squared is 9. This gives me 9 equals x minus 5. I should add 5 to both sides and get 14 equals to x. I claim that's the answer. Let me check to make sure the log base 3 of 14 minus 5 equals to 2. This calculator is so much better. If I did math log base, the log base 3 of 14 minus 5, it works perfectly. On this calculator, I would have to do the log of 14 minus 5 divided by the log of 3 to check. They both check just fine. They both boil down to 2 equal to 2, so I know I'm good. So 38, I get the log base 3 of 3x equals 0. Rewrite it in its exponential form. It's going to be 3 to the 0 power equals 3x. When I free the 3x from the logarithm, it doesn't need to be in a parentheses. So I scratched out the log, made the 3 the base of the exponential function, switched the 3x and the 0. This is going to give me 3 to the 0, which is 1, equals to 3x. Solve for x by dividing both sides by 3. This will give me 1/3 equals to x. I'll come over here and check and make sure the log base 3 of 3 times 1/3 equals 0. I don't even need a calculator for this. 3 times 1/3, because the reciprocals are equal to 1. And the log of 1 is equal to 0 in any base. I don't need a calculator, but I could use whatever calculator I own and do as much math as I want to. This is entering the whole thing without any simplifying, and it works there. Or I could enter that on this calculator. This would be hard to enter. This would be easier. I would do log of 1 divided by log of 3. And regardless of what, they're going to check just fine. The next 4 problems, I need a new strategy. I don't have a log on the left-hand side and an integer on the right-hand side, or a constant on the right-hand side. On 39, 40, 41, and 42, I have one logarithm the same base equal to another logarithm the same base. These are super easy. For these, you just drop the logs, set the arguments equal to each other, solve for x, and check. The checking is ugly-ish because you're going to get decimals. So in problem 40, structurally different. There's a logarithm, same base on both sides. And when you have that set up, it's enough just to drop the logs without doing any switching. If the right-hand side didn't have a log, I couldn't do this. But when you have one logarithm, the same base, equal to another logarithm, that base, it's enough. You can just drop the logs and set the arguments equal to each other. The arguments don't need parentheses anymore once the logarithms are gone. So that would be the problem written without the logs. I snuck a 1 in front of this x just because it's to make my algebra easier. To solve this, I'm going to minus 1x from both sides and get minus 4 equals 1x minus 10. Add 10 to both sides and get 6 equals to 1x, or 6 equals to x. I claim that's the answer. These are ugly to check because both sides are going to come out to decimals, and I'm not even going to write the decimals down. Just going to make sure that the left and the right side match perfectly. And this is now, any calculator can do ln's. So here, the left side is the ln of 6 minus 4, which is that number. The right side is the ln of 2 times 6 minus 10. Better get the same number. I do, so I know my answer checks perfectly. Even though I wouldn't care to write those decimals down, they match. It's exactly the same keystrokes on this. The left side is the ln of 6 minus 4. The right side is the ln of parentheses 2 times 6 minus 10. Just like that, and you get a perfect matching. (41) and 42 structurally the same. 42 has the log base 4 of some argument on the left side equals the log base 4 of some argument on the right side. And when you have that, logs the same base on opposite sides of the equal sign, you can solve by just dropping the logarithms and setting the arguments equal to each other. When I drop the logarithms, I don't need the parentheses anymore. So I drop the logs, set the argument of 3x plus 6 equal to the argument of 4x. I'm going to minus 3x from both sides and get 6 equal to x for my answer. I'm going to check it on my calculator only. I'm probably not going to write down the decimal. Left side is going to be that. Right side is going to be this. This calculator is easier to check but harder to see. So I'll check on this calculator. On this calculator, I don't want to have to do so much. This is 18 plus 6 is 24. Well, maybe I don't even have to check. And this calc side is a log of 24 as well. These have to be equal to. Log base 4 of 24 has to be equal to log base 24. There's no sense in pulling out my calculator. When I simplify the radicands, it's painfully obvious that these equal, so I'm not going to check. I'm just going to say those actually do check. They check perfectly. Those have to have the same decimals. Now some grunge. The grunge that always comes on the test because these problems always come up. So, in problems 43, 44, 45, 46, 47, we'll do probably these two and then start a part 3 to this section, which I don't care to do, but it's going to have to happen. For these two problems, there's 2 logs on the left-hand side and a constant on the right-hand side. When this is a setup, when the left-hand side has 2 logarithms, the same base, separated with a minus sign, the steps to solve this problem is first, use the minus to divide rule to write the left side as one single logarithm. I don't know if I have my rules that close. I'm going to use this rule in reverse. If I have 2 logarithms, the same base, separated by a minus sign, I'm going to make those 2 logarithms into a single logarithm with a division. So, in problem 44, to get started, make the 2 logarithms on the left-hand side into a single logarithm by dividing their arguments. Could use a parenthesis here, that would look nicer, but it's not required. That's step 1. Now I'm going to rewrite the problem in exponential form. I'm going to cross out the logarithm. The 3 is going to remain low. I'm going to switch the -1 with the fraction x over x plus 6. That's all of this. It's just telling me to do that. I tried to write the steps down that explained how to scratch out the log, leave the base low, create your exponential functions. Now I need to solve for x. I'm going to need to cross multiply to solve. I better get 3 to the negative 1 written as a fraction. I know what it equals to, but I'll pretend I don't. 3 exponent negative 1 is, if I math and enter twice now, so if I get it like this, math and enter, 3 to the negative 1 is 1 over 3 to the first power, which is 1/3. So 3 to the negative 1 power is 1 over 3 to the first power, which is 1/3. So I can rewrite this as 1/3 equals x over x plus 6. In my efforts to solve, I'll need to cross multiply. So let me do my cross multiplying. To cross multiply, both sides need to be a fraction. Now I'm going to cross multiply up and get 3 times x. Cross multiply down and get 1 times x plus 6. This gives me 3x equals 1x plus 6. I go 1 times x and 1 times 6. I'm going to minus 1x from both sides. This is going to give me 2x equals to 6. And then divide by 2, divide by 2. This is going to give me what I believe my answer is, which is x equal to 3. I better check. So for checking, it needs to be that the log base 3 of 3 minus the log base 3 of 3 plus 6 equals to negative 1. This is a lot to do on this calculator. Let me do one logarithm at a time. The first logarithm is the log of 3 divided by the log of 3 on this calculator, which is 1. The second logarithm is the log of 9, because this is 3 plus 6 divided by the log of 3. So the second logarithm is the log of 9 divided by the log of 3. The second logarithm is 2. So this gives me 1 minus 2 on the left-hand side. The left-hand side simplifies to negative 1, and that equals the right-hand side. Would be way easier to check on this calculator. On this calculator, I could just do it all. I could just go math log base, the log base 3 of 3 minus math log base, the log base 3 of, and I'm just going to enter 3 plus 6, play dumb that I couldn't even add 3 and 6, and it comes out perfectly to the negative 1. So much easier when you have log bases to check with logs. I might be able to get this whole video done and not have to do, how many problems do I have? Yeah, maybe. Let's see what happens. 45 and 46, there's a minus between my two logarithms. The logarithms are the same base. All the steps, 43, 44, 45, 46, 47. First step, make the two logarithms into one using the minus to divide rule. So in 46, I'm going to get started. I'm going to say this is the log base 3 of x minus 5 over x plus 3 equals negative 2. Done with step 1, on to step 2. Scratch out the logarithm, switch the negative 2 with the fraction, and now make it so I can cross multiply. When you're doing problem 45, you're not going to get a fraction naturally. You're going to have to write the left side over 1. Maybe I'll do that. My problem is going to give me 1 over 3 squared equals x minus 5 over x plus 3, which is going to give me 1/9 equals x minus 5 over x plus 3. And now I'm going to cross multiply and do 9 times x minus 5 equals to 1 times x plus 3. That's going to give me 9x minus 45 equals 1x plus 3. I'm going to minus 1x and plus 45 minus 1x and plus 45. This is going to give me 8x equals to 48. And then divide by 8, divide by 8. I get x equal to 6. Let me check this to make sure the log base 3 of 6 minus 5 minus the log base 3 of 6 plus 3 equals -2. If I'm checking on my harder calculator, I should write this as a log base 3 of 1, which is 0, minus the log base 3 of 9, which is 2, equals to -2. So on this calculator, let me do each log separately. The first log is the log of 1 divided by the log of 3, which is 0. The second log is the log of 9 divided by the log of 3, which is 2. This gives me 0 minus 2 equals to -2, and it works perfectly. Rather than rushing, let's do 45 together, and then we'll do a part 3 to this, so I don't have to rush. So just in case you tried 45 and got stumped, let's do it. So on 45, I need to make the 2 logarithms into 1. My first step is going to make the 2 logarithms into 1, make it the log base 2 of x divided by x minus 6 equals to 2. That's the end of step 1. Step 2, cross out the logarithm, switch the fraction with the constant to the right of the equal sign. That gives me 2 squared equals x over x minus 6. This is where your problem is a little bit different. The left-hand side doesn't simplify to be a fraction because 2 squared is just 4. I want to solve by cross multiplying. Since the left-hand side doesn't naturally come out to a fraction, I'm going to make the left side a fraction by writing it over 1. I'm going to multiply both directions, put the bigger coefficient on the left-hand side to make the math easier to follow. This gives me 4 times x minus 6 equals to 1 times x. This gives me 4x minus 24 equals 1x. Now I'm going to minus 4x minus 4x. That will give me -24 equals -3x. Divide by -3, divide by -3. That's going to give me 8 equals to x. And I need to check that in the original problem. And I'm just going to check on this calculator, assuming you can check on your other calculator. So on this calculator, I'm going to change this x to 8, do the log base 2 of 8. I don't know what I just hit. Log base 2 of 8 minus the log base 2 of 8 minus 6, changing that x to 8. And when I hit enter, it better equal to 2 because I'm entering 8 for the x's on the right-hand side, which I think my answer is, and on the left-hand side, and the right-hand side is 2. So it works perfectly. I can check it with my other calculator, but I won't. Your problem 47 is another one of these with a minus between. On part 3 of the video, we'll do these kinds of problems with a plus between, and those are kind of the hardest problems, so it's probably nice that we set those in their own separate video so that you can not have any distractions. So there's still a few more problems. Those few more problems come on the test. Don't skip part 3.